Let's discuss question number 5 from test 1. The topic is mechanics. Basically, the question is from engineering mechanics. Let's read the question. A flywheel rotates with uniform angular acceleration. Its angular velocity is increased from 20 pi radians per second to 40 pi radians per second in 10 seconds. And so what is asked is how many revolutions did it make in this period. So you have a flywheel, okay, which basically undergoes fixed axis rotation about its center, okay, and the initial rotation is given, let's call it omega 1, 20 pi radians per second. Initial angular velocity is given, and in 10 seconds it comes to final angular velocity of 40 pi radians per seconds. So this it goes in 10 seconds. Okay, that means t2 minus t1 is 10 seconds. Now another important information is that angular acceleration is uniform, or what it means is it doesn't vary with time. So angular acceleration, which is alpha, is constant. That is what it means. It doesn't vary with time. That's what the meaning of uniform is. Okay, so now just like we have kinematic relations of V is equal to U plus AT and S is equal to UT plus half AT square, and your V square is equal to U square plus 2 as well. These are for linear motion, a particle or a body in linear motion with constant acceleration. Now similar to these, we have in rotational a body in, so this is for linear sense, okay. Now if a body is rotating with constant angular acceleration, so this is for linear acceleration. We have these three equations. Now say, so this is like if you have a body and which is moving with a is equal to constant, acceleration is constant, these equations we have for that body. Now similarly in the rotational sense, if a body is rotating, pure rotation, okay, the center is fixed and it is rotating about its center, we have similar set of equations just parallel to these things but in rotational sense. So this is very important because most of the time there is a question on rotational sense. You can just apply these equations when alpha is constant or angular acceleration is constant. So similar to these, whatever I have written here, we have omega. So here V was final, U was initial. So I am just calling omega 2 as final, omega 1 as initial. So it's something like this. So these equations just transform in this way. The first equations transform in this way. The second equation gets transformed in this way. And the final equation gets transformed in this way. Now, so remember that these are only when alpha is constant, and this problem you have alpha constant. Okay, so we can use this equations. So 2 alpha theta, remember, so S changes to theta, U and V changes to omega 1 and omega 2, basically the velocity is changed to, and A changes to alpha. So this is what you have to convert. So this is how your linear acceleration changes to rotational acceleration. Basically, I mean, all this happens when acceleration is constant. So these you would have studied in standard 12th, but now we need to apply for rotational sense. So it's now the matter of what is asked and what is given. So now what is given is omega 1, omega 2 is given, angular velocities, time is given. So we can use first equation and get alpha. (40 pi minus 20 pi by 10), so this comes out to be 2 pi radians per second square. Now we want theta, that is in how many revolutions does it make in time t. So basically we are interested in theta and initial and final angular velocities are given, alpha we have just calculated, so it's better if you use directly this equation. So theta is omega 2 square minus omega 1 square by 2 alpha. Omega 2, remember, it is given in radians per second, so let's substitute in radians per second. So this we get some 1600 minus 400 pi square by 4 pi. This comes out to be your 300 pi radians, because everything was in radians, so we got in radians. But what is asked in revolution? So in revolutions, the angle moved or the rotation, the revolutions, in revolutions the angle moved is, so we have in radians, we need to basically divide by 2 pi to get in revolution, because one revolution is 2 pi radians. So in order to get in revolutions, we have in radians, we need to get in revolutions. So it's basically something like this: 300 pi radians is how many revolutions. So the same thing we are doing in this way, 150 revolutions. So let's look at the answer is D. Thank you.